Real people, real opinions, Real Talk Radio. The multi-award-winning Niall Boylan Show.
Ireland's classic hits.
It is that time of the night again where Jane finds a random person in the world who's an expert at something and never tells me about it until I come into the radio station, and then she hands me a sheet with a bit of information on it, because we have this deal between the two of us that I don't really want to know too much about them, because I want to find it as interesting as you find it, listening to people. So basically, we were talking in the last hour about cosmetic surgery, and no one wants to look old. We don't. Let's be honest with ourselves. I know we like to grow old gracefully, some of us, and some of us will get cosmetic surgery, but nobody wants to do it gracefully, generally speaking, nowadays. We spend a lot of money trying to, I suppose, look well, but what actually works? How can we keep our youthful appearance? I think I'm keeping my youthful appearance. Anyway, have you ever bought any anti-aging creams or checked your hairline? Well, this next guest is certainly for you. Andrew Steele is a scientist, a writer, and a campaigner who's based in Berlin. He's also the author of Ageless, a new science of getting older without getting old. After a PhD in physics from the University of Oxford, he decided that aging was the single most important scientific challenge of our time and switched fields to computer biology. Since then, he has made a living out of keeping us young. And I have a big birthday coming up next week, so I'm really looking forward to this. I'm 60 years of age next week, so maybe Andrew can help me out as well. Andrew joins us. Andrew, hi, how are you?
Good evening, very well, thank you. How are you?
Good. Andrew, look, this is the fountain of youth, as they used to call it years ago. It's the age-old question, pardon the pun, of can we actually turn off the aging process? I know there's great work being done at the moment, and I remember reading something recently where they believe they actually can, but can we turn off the aging process?
I think we really can, yeah. So, there have been developments in science in the last couple of decades where we've made huge strides, firstly in understanding the aging process, so we can now break down all the different things that are happening in your body as you get older. And these are the underlying cellular, they're the molecular changes that give rise to everything from wrinkles and grey hair, the sort of cosmetic stuff you were talking about, to the much sort of wider-ranging health consequences, the cancer, the heart disease, the dementia. And you mentioned in that introduction that the reason that I changed career is because I think aging is our single most important scientific challenge. Fundamentally, this is why, we all do like to look young.
It would also, by the way, it would also make you very rich. If you cracked it, Andrew, it would make you very rich too. Because everybody will try it. It's like diet. For women, dieting particularly for women is the big thing, right? You bring out a diet product, you're a millionaire if it works. The same with aging. We've seen so many aging creams. I see ads on Facebook and TikTok all the time for these creams you rub on your wrinkles and they suddenly disappear. That's temporary, mind you. But let's talk about the aging process. So somebody told me a while ago about this, the cliche, the 7-year itch, that it's something to do with some factual thing in science where your cells replenish themselves every 7 years, every cell in your body. So we actually do change every 7 years. But do the cells continue to replace themselves on a molecular level for the rest of our lives, and we just die of heart attacks or whatever it is? So why do we get wrinkly? Why do we get tired? Why do we get old if our cells are that good at replacing themselves?
Well, the way that I try and define aging actually first is to zoom out from the sort of nitty-gritty biology of the situation. And actually 7 years is a really important number. It's something called our mortality rate doubling time. So let me break that down. Mortality rate is how likely you are to die in any given year. And doubling time is how long it takes for that risk to double. So let's give an example. I'm 38 at the moment. And what that means is that my risk of death this year is about 1 in 1,000. And I quite like those odds because, if you think about that, if that were to continue for the rest of my life, I'd live into my 1,030s on average, but clearly that isn't the case. And so if you carry on doubling and doubling and doubling that number, if I'm lucky enough to live into my 90s, but unlucky enough that we haven't unraveled anything about the aging process in the intervening time, I'll have a risk of death more like 1 in 6 every year in my 90s. That's sort of life and death at the roll of a dice. So, fundamentally, we want to understand what gives rise to this huge increase in risk of disease, which then causes an increase in risk of death. And in my book, I break it down into 10 what are called hallmarks of the aging process. So these are these fundamental cellular, molecular, biological processes. I'm not going to go through all 10 of them now for you listeners. I know it's a bit late in the evening for that sort of thing. What I'll do is I'll pick one and try and go through that in a little bit of detail. So there's one that's called the accumulation of senescent cells. And senescent is just the technical term for old, basically. These are cells that have been around in your body a long time. Perhaps they've divided a lot of times. That's that cell replacement you were talking about. Perhaps they've got some damage to their DNA. That's the genetic code inside of all of them that gives them, the instructions as to what they should do as cells. But if they've divided a lot of times, if they've accumulated that damage, they then stop dividing. That's a very sensible move, by the way, because it's a cancer prevention mechanism. It stops those cells dividing repeatedly and forming a tumour. But the problem is that as we get older, we accumulate more and more of these cells in our bodies, and they essentially accelerate the aging process, which could be quite a depressing idea, right? But the good news is that scientists have drugs that can kill these senescent cells while leaving the rest of the cells of the body intact. And there was a really cool experiment that was published in 2018. It was just done in mice. What they did was they gave mice some of these so-called senolytic drugs, and the mice basically got biologically younger. So they waited until they were 24 months old, which is quite old. It's about sort of 60 or 70 years old in mouse years, as it were. Mm-hmm. And what they found was they lived a bit longer, which is good news, but they didn't stretch out that period of frailty at the end of life. The mice actually got less disease, they got less cancer, they got less heart problems. They were indeed less frail. They had these tiny little mouse-sized treadmills in the experiments, and the mice could run further and faster after a dose of these drugs. They seem to be less cognitively aged. And frankly, it's very much worth your listeners going online and looking for a picture of these mice that have had senolytic drugs, because you do not need to be an expert mouse biologist to see the ones that have had the drugs. They just look fantastic.
So where do I buy these drugs?
Well, very good question. At the moment, there are 20 or 30 companies that are doing human clinical trials, trying to turn this from an idea that works, in cells, in mice in the lab, into something that we can actually, use in medicine. And that's the real dream of this anti-aging stuff, not a skin cream, but something that can go in and fundamentally slow down the aging process and affect potentially the whole of our biology.
And so when we talk about human trials, what are we looking at? 5 to 6 years in human trials? Do you see a day, reasonably soon in my lifetime, and maybe mine, certainly in yours, you're a bit younger than me, where we'll be able to pop a pill, every day, after we get to the age of, say, 30, which is probably where we start to go downhill, and it will stop that aging process, or certainly slow it down and give us another 100 years of our lives. Do you see a day when that happens?
Well, I hate putting numbers on how many years of life we're going to get, but I will say that I think these things are going to come in time for most people alive today. And the reason I say that is, as you say, there are clinical trials going on right now. We should have results of those in the next 5 years. Senolytics aren't the only game in town. I said there are 10 hallmarks of aging, so there are 9 others that we've got ideas for as well. There are various other kinds of drugs that could be existing drugs that might have an anti-aging effect that scientists are looking into.
I mean, look, we have come a long way, haven't we? I mean, the last 100 years, we're living longer, well, thanks to modern medicine. And particularly when it comes to, women and the aging process, the HRT and all those kind of hormone replacement therapies. And that's all helped us to live life longer and live healthier longer as well. But are there ways, that we can, our tips, things that we can do, apart from the obvious of not drinking and smoking, are there things that we can do to kind of ourselves, without taking drugs, to reverse that biological age?
Well, I split these things up into a few different categories. And the first, unfortunately, are those obvious ones like, not smoking, not eating too much, getting regular exercise. But I think something that I really came across as I was researching, more and more about aging biology, is that these sort of can sound quite boring bits of health advice, can't they? We've heard them lots of times before. But when you understand the aging biology, you realize that they are literally slowing down the aging process. So I think that makes the sort of everyday bits of health advice a little bit more exciting. The second category is things that you probably wouldn't anticipate without a bit of understanding of the biology behind the aging process. And into that category, I think my favorite example is brushing your teeth. Now, you might think, what on earth has that got to do with longevity? There are obvious benefits of brushing your teeth from a not getting painful cavities point of view, but how could that possibly affect how long I live? Well, the first studies that were looking into this in sort of the 1990s, they found that people who had better oral health, so better health in their mouths, tended to have less heart disease. Now, this is a classic case where scientists say maybe correlation doesn't equal causation.
I get you.
Maybe it's just that the people who brush their teeth really well, maybe they're also very health conscious, maybe they've got a better diet, maybe they
exercise more, they look after themselves,
Exactly.
That's like an example somebody gave me years ago and said to me, well, vegans live longer than non-vegans. And I said, well, actually, no, they don't. That's a correlation. The chances are if somebody's vegan, they're probably health conscious and they're looking after themselves a bit better rather than somebody who's sitting eating 4 steaks a week. Do you know what I mean? So I think there's probably a correlation, but I do get the correlation in that. Yeah.
So the idea is that the scientists, obviously scientists know this happens as well, and so they decided to do more research. And they found that actually there is a biological link that's going on between your mouth and your heart. And that biological link is something called chronic inflammation. This is one of the other hallmarks of aging, essentially. It's a gradual increase in your body as you get older of how paranoid your immune system is. So your immune system is a really crucial part of your biology. It's what wards off infections, so it fights bacteria, it fights viruses. It also does things like spotting those senescent cells and spotting cancer. So it's sort of cleaning up your body in loads of different ways.
Mm-hmm.
But unfortunately, as you get older, it gets a bit hyperactive, it gets a bit paranoid. And this hyperactivity, so-called chronic inflammation, so this ongoing inflammation, can again accelerate the aging process. And what we think is going on in terms of your teeth is that if you have gum disease or if you have tooth decay, these are bacterial infections in your mouth. And what we know from dentistry is it can be a little bit medieval sometimes. You know, they go in, they drill out the gaggy bit of tooth and they fill the hole with some metal or some plastic or something like that. The reason dentistry is in some ways so primitive is because your immune system can't win that battle. It can't defeat those bacteria in your mouth. And so if you have got something like gum disease, it's this constant ongoing immune system battle happening in a part of your body. What does that sound like? That is that chronic inflammation process that I was just talking about.
Mm-hmm.
And so we think that does have a causal link with the health of your heart, because chronic inflammation can accelerate heart disease. There's even some evidence that it could be linked with dementia, because people have found the bacteria that cause gum disease in the brains of people with dementia. So we're not 100% sure which way that link goes yet, but as we understand a bit more, hopefully we'll find out. And in the meantime, I'm going to carry on, brushing my teeth and flossing and doing everything I can.
I'm now going to make that extra effort to make sure I do them 2 or 3 times a day rather than just the once or twice. But I mean, a lot of the stuff that we have found, and I'm sure you have found this too, I suppose, through biology and medicines, we find by accident. Like I was only reading some research now recently, and I don't know how true it is, that, of course, Viagra, which is one of the most popular drugs in the world, was found by accident because it was originally meant to stabilize blood pressure. But now they're saying with Viagra that now I don't know, you could clarify this, you probably know more about it, is that is Viagra itself, for men taking Viagra on a regular basis, it slows down the process of dementia or stops them getting dementia altogether. Now, I don't know, again, how true that is. I was reading an article about it. Some people say it's true and some say it's not. So I don't know how good those studies are. So in other words, the point I'm trying to make is we tend to find these things out by accident, by people using different drugs in the long term.
Yeah, exactly. And I think there's a very interesting link there, actually, between blood pressure. You said, that's what Viagra was originally developed for, and dementia. Often we don't necessarily think of the health of our heart as being associated with the health of our brain. But actually, Alzheimer's disease is the most famous form of dementia that's associated with these sort of tangles of protein that we find in the brain. But almost as common is another kind of dementia called vascular dementia. So this is dementia that's associated with the blood vessels in the brain. And if you imagine, when you've got high blood pressure, that means that every blood vessel in your body is being battered by this high pressure every time your heart beats, right? And so if you've got these tiny, delicate little vessels in your brain, sometimes, after being pummeled 60, 100 times a minute every single day, 24/7, these little vessels can just burst. And if it was a big vessel, that'll be a stroke. That's a very serious thing. You have to rush to the hospital. But if hundreds of thousands of the much, much smaller blood vessels start to burst or start to, get less effective at delivering the food and the oxygen that the blood brings to your brain, then that can cause this vascular dementia, this sort of slow, it's effectively, perhaps hundreds or thousands of micro strokes, which eventually go on to cause very similar symptoms to other kinds of dementia. So it's quite plausible that a drug that works on, a Viagra that works on blood pressure could improve your brain health. And that's actually another reason why exercise is so important. You imagine it helps the health of your heart. It clearly does. You can feel your heart beating when you go for a run, when you go for a bike ride. But also it's helping the health of your brain by keeping your blood pressure down.
Does it blow your mind, even though you're involved in the industry for so many years and you've got a PhD and you understand the human body and how it works a lot more than I would, or most, your average person does, but does it blow your mind how incredible the human body is? And I was only talking to somebody recently about the human heart. We've got some of the best hydraulic pumps built by some of the best companies in the world. Even the engine in your car, which is built by people who've been studying this and designing engines for years. And yet we could never develop a pump that could continually run for 100 years or close on 100 years. So the human body is just one unbelievable instrument, isn't it?
I think it's absolutely incredible. One of the best statistics I worked out myself, actually, while writing the book, was that when your cells divide, they have to copy the DNA that's inside those cells, so the instruction manual that makes sure that both cells have a copy of that instruction manual. And your cells are constantly renewing, as you said earlier. And what that means is that our cells are dividing, every minute of every day our cells are dividing and replacing cells that have died. And over the course of your lifetime, that means that you will produce about 2 light years of DNA. That means enough of this instruction manual molecule, if you were to stretch it out end to end, it would reach halfway to the nearest star.
Wow.
And yet, it makes almost no mistakes. There are 6 billion letters in your genetic code. It's made up of A's, T's, C's, and G's, these chemical letters. And yet, it hardly ever makes a typo.
I'm actually getting a chill thinking about how incredible that is. And
really mind-blowing.
Oh, and then when we talk about the human brain, and I watched a documentary one night, and they showed you this guy, somebody threw a ball to him, and he caught it in one hand, and they talk about what's involved for the human body to catch that ball. Your brain has to, work it out. Your eyes have to look at it in 3D, see how quick it's traveling. Your brain then has to calculate its speed, calculate the speed, and then calculate how quickly your hand can lift up, how quick you can open your hand and then close it at just the right moment. All of these calculations, there's not a single computer in 2023 in the world that could do that as efficiently as we can as human beings. So this shows you how important our bodies are and how incredible they are.
It really does, yeah. And I think what's most amazing about the human brain is, we use ChatGPT. ChatGPT is running in some massive server farm somewhere with, hundreds and hundreds of computers all wired together in very clever ways. And our brain is better than ChatGPT, and yet it operates on just 20 watts of electricity. So that's about as much electricity as a light bulb. And yet it's doing these incredible calculations in real time as you catch a ball. It is just, it's literally mind-blowing, isn't it?
Is it is that what your brain runs on, 20 watts voltage of electricity?
Yeah.
And how does the body generate electricity?
Well, in this case, the watts is sort of a power equivalent. So,
okay.
What's really interesting actually is that the way that we generate energy is effectively we burn sugar. The chemical reactions are done are slightly more complicated. You'll be happy to hear slightly more delicate way than simply burning the sugar. But we take sugar and we combine it with oxygen, which is obviously what we breathe in. So we eat the sugar, we breathe the oxygen, and that creates water and carbon dioxide plus some energy. But what's truly remarkable is that inside our cells, and then this is another thing that goes wrong during the aging process, we have these little power plants. They're known as mitochondria. And these tiny little things inside our cells are buzzing around. And across their membrane, they're effectively in a little bag. And across that little bag is so much electricity in such a tiny space, it's actually got about the same voltage per distance as a bolt of lightning.
Wow.
And so there are all these millions, billions of controlled bolts of lightning going on in all of your cells all the time, generating that energy that's allowing us to, chat, have this conversation, move your muscles if you're exercising, whatever it is. That heart beating, 60 times a minute every single day is being powered by these tiny little sort of captured lightning bolts burning sugar.
Incredible.
It's incredible.
When you describe that, it's just incredible to listen to you to even describe that as well. And where are we when it comes to cryogenics, which was a big thing back in the 80s, where rich people decided, if I freeze myself now, I can escape the aging process, and hopefully they will have a cure for it at some point. Now, I don't know if any of those people are still in cryogenic boxes or with coffins or whatever they had all over the world. Is it possible? Like, this thing I've seen experiments that do with a fly, that you put a fly in a freezer and he will be literally frozen to death. You put him on your hand, you warm him up, and he comes back to life again. Is it possible that human beings, and I don't know whether that's real, but I've seen it on TikTok, is it possible that human beings will ever be able to freeze themselves until such a point as we find a cure for whatever it is wrong with them?
There are some really remarkable stories, actually, of people who have had, terrible accidents, and they've had them out in the wilderness, but they've been fortunate enough to slip into some freezing pond, and it's kept their body essentially in a state of suspended animation. And once they went to hospital, often hours and hours later, during which time they'd definitely have died if they'd stayed at normal temperature, they're able to be revived. Now, whether we can do that, on purpose and store people for decades and decades, that's a really open question. But I actually went to an aging conference recently where there were some people doing some really interesting work, not trying to cryogenically freeze a whole person, but thinking about doing it for individual organs. And this is a hugely important and exciting idea. It's also much easier than freezing an entire human body, because obviously human bodies are very big. It takes a really long time to cool them down. You have to be super careful. But if you had something like a liver or a heart that's really, really needed by someone, could be all the way across the country, what you could do is you could cool it down into a state where it's below freezing, where you can effectively store it as long as you like. And what that would mean is that thousands of people's lives could be saved. because loads and loads of people die waiting for a donor organ. And one of the real challenges is that when you donate an organ, you need to find a donor who matches the person who wants to receive that organ, because otherwise the recipient of the organ might reject it. Their immune system might effectively fight their new organ and cause huge problems for them. So what you need to do is find a donor and a recipient who can match up. And that's a real challenge. But if we could cryogenically cool these organs down and store them, potentially drive them slowly to exactly the right person without having to do everything in a huge rush, this could be something that could save thousands of lives. So maybe we're not going to be cryogenically freezing billionaires anytime soon. But if we could just develop this technology and get it working on organs, it could be a real lifesaver.
And I suppose finally we need to get into the artificial way of stopping ourselves from aging. There's any amount of creams and aging creams and, different vitamins and things we can take currently at the moment. Do any of them work, or are we just being fooled by clever marketing companies?
I think at the moment it's all marketing, and we're in this very strange transitional time when it comes to aging biology, because we really do understand more than we ever have understood, and we understand enough that we can make these interventions in the lab. We've got dozens of ways to slow down the aging process in mice or in cells in a dish. And the real challenge is what are going to be the first ones that make it to human use. So we're at a time where there's lots of exciting stuff to sort of grasp that. There's lots of promising experimental results that these supplement companies can point to and say, this is something that has some precedent in the lab. But I think the single most important thing we need to do if we want to live longer, firstly, is the basic health advice. It's exercise, it's eat well, it's do all the stuff your mother would have told you. Secondly, it's probably not bother with most of these supplements, because in supplement skin creams, a bit of moisturizer isn't going to do you any harm. The best anti-aging skin cream actually is sun cream, because it prevents the UV damage from the sun, which is the key driver of skin aging. But if you really care about slowing down the aging process, the most important thing you can do is learn more about this aging biology and spread the word, because I really don't think that enough people understand the potential of this science. We literally have drugs and other interventions that can slow down or reverse the aging process in the lab. And to get those from the lab into people, I think that's why I'm so excited by this stuff. It's our biggest scientific challenge. It could massively reduce the incidence of diseases like cancer, diseases like dementia, the leading killers in the modern world. You add together all of these diseases. Of the 150,000 people who die every single day on planet Earth, more than 2/3 of them, so more than 100,000 people per day, die essentially because of aging. And so if we can just slightly defer, slightly delay those diseases, we can keep people healthier for longer. You can carry on, being independent, living independently, getting on with your hobbies, playing with your grandkids, hanging out with your friends, going on holiday, all of these fantastic things about being alive. And if we can just deliver that to as many people as possible, that's what really excites me about this stuff.
I mean, Jane, my producer, is getting extremely excited here. She keeps saying in my hand, I want more tips. So and some of our listeners, somebody says, is this live, by the way? Because I want a few tips. It is live. But so people are texting in, I suppose, looking for tips. This is what people want all the time. Those drugs that you're talking about, I'm excited about those. I think many people are excited even thinking about that. But that's probably going to be 10, 20 years away, at least, I would imagine.
I think it might be sooner than that. So there's a drug, for example, called metformin, which is a currently existing diabetes drug. In fact, a lot of people listening right now might be taking this drug.
What's it called? What's it called again?
It's called metformin.
Okay.
It's a drug. It's the most commonly prescribed drug for what's called type 2 diabetes. So this is the diabetes you get later in life, rather than diabetes that you develop as a child. And what we found is that people taking metformin who have diabetes seem to live slightly longer than people who aren't taking the drug because they don't have diabetes.
Right, okay.
And that's a slightly strange result, because normally people who have diabetes, they tend to be more overweight. Diabetes comes with a few health problems, like cardiovascular problems associated with it. So the fact that they're outliving non-diabetics who aren't taking the drug is a really remarkable result.
There's loads of people listening now going to go to the doctor tomorrow and pretend they have diabetes just to get the drug.
My blood sugar's looking a bit dodgy. We need a proper randomized trial to check this works in non-diabetics. But that's a potential drug that, because we've been prescribing it, for about 50 or 60 years now, we understand how it works, we know it's safe. And so if this could be shown to be an anti-aging medicine, it's not going to be 20 years away. This is something that could happen much, much sooner than that.
But the other tips that we talked about, hydrating your skin with moisturizers. I suppose hydrating your skin is no harm. It keeps your skin looking a little bit younger and hydrates your skin. Things like, say, the other things that people talk about are, going to a sauna on a regular basis, or exfoliating your skin, or all those. I'm assuming that's all just external, and that doesn't make a huge difference to how long you live.
It's an interesting, saunas are a particularly interesting question. There are some really fascinating studies coming out of Finland, which is obviously the sauna capital of the world, that suggest that people who go to the sauna more often might see health benefits beyond the cosmetic, things like reduced risk of heart disease and stuff like that. The real challenge is that, unfortunately, again, there's this correlation-causation issue, because if you say the people who, in Finland, a lot of people go to the sauna, but if you say the people who go to the sauna 4 to 7 times a week, I think was the top category in the study that I saw. If you're someone who's got time to go to the sauna 5 times a week, you're probably living a relatively chilled
You're
out
not
life
working,
in
you're
other
not
ways.
working too hard. Yeah.
Exactly.
Yeah.
And the other challenge in that study was because Finns are such heavy sauna users, they weren't even able to create a control group because they couldn't find enough people who didn't go to the sauna to put into that group.
They do it on Christmas Day. It's a tradition. Or Christmas Eve, the whole family go to the sauna together in the nude. And that's a very strange culture.
Definitely, it's been a new experience for me since moving to Germany.
Well, listen, I have to say, Andrew, it has been intriguing talking to you. I just find it fascinating. Listen, particularly the way you explained everything. It was fascinating to listen to. Hopefully, we will all find the fountain of youth, because people like yourselves will keep looking and studying all the time. If people want to get your book, by the way, it's called Ageless: The New Science of Getting Older Without Getting Old. It's a good title, by the way. The New Science of Getting Older Without Getting Old is called Ageless, if you want to. And I'm sure you can get that on the usual places, Andrew, Amazon, everywhere else. And
yes, you can, and you can actually find it by going to ageless.link is the quickest way to get hold of a copy.
Okay, ageless.link.
Real people, real opinions, real talk radio. The multi-award winning Niall Boylan Show.